Hi, hello students, welcome back. I hope you are doing good. So, have you ever wondered how to prepare an alcohol from an alkene? How to prepare an alcohol from an alkyl halide? How to prepare an alcohol from your aldehyde or ketone? The answers for these questions you will be understanding in this part. So, in this part we will be discussing about how to prepare an alcohol or phenol or an ether from different organic compounds. So, let us start with our part. Preparation of alcohols. So, what are the different methods to prepare alcohols? So, you can get alcohols from the following. You can get alcohols from alkenes. You can get alcohols from alkyl halides. You can also get alcohols by reduction of your aldehydes and ketones. And not only that, if you can reduce your aldehydes and ketones to alcohol, that means you can also reduce the higher compounds like carboxylic acids, esters and acid chlorides. So, reduction of your carboxylic acids, esters and acid chlorides also gives your alcohols. And not only that, from primary amines you can get alcohols, from oxiranes you may get alcohols, and fermentation of carbohydrates. So, let us understand one by one. From alkenes. So, here you can see the different methods to prepare a given alkene into alcohol. Now, if your reagent is H2O and H2SO4, you will be getting a 2-degree alcohol, because here the first step is formation of carbocation, and you know that a 2-degree carbocation is more stable. So, that is why you have a 2-degree alcohol. You have a concentrated H2SO4 and H2O. It is the same thing, but in the first step itself you are using concentrated H2SO4 and then you are hydrating it. Then also you will get a 2-degree alcohol. Not only that, if you use Hg and OCO CS3 twice and H2O, then you are reducing it with sodium borohydride, then also you will get a 2-degree alcohol. This is important because whenever you are using a peroxide and whenever you have a boron trihydride, what is happening is that you are getting an anti-Markovnik's product. Till now all these products are Markovnikov's product. According to Markovnikov's product, 2-degree carbocation is always favored in formation of alcohol than 1-degree alcohol. So, according to anti-Markovnik, it is the reverse. That means 1-degree alcohol is favored than a 2-degree alcohol. Not only that, you can get from oxo process, and in oxo process what you are doing, you are using carbon monoxide and hydrogen, then you are using this complex where you are using cobalt and carbonyl. So, it is nothing but tetracarbonyl cobalt. So, you are using it. The first step is aldehyde. So, I can convert an alkene to aldehyde by using oxo process in the first step. If I reduce an aldehyde, I will get an alcohol. So, oxo process is important process because in the intermediate step I will get an aldehyde. That aldehyde can be converted into alcohol by reducing it. From alkyl halides. So, alkyl halides gives alcohol with KOH or NaOH or else with moist Ag2O. So, there are two steps, there are two reactions which can be possible. The first reaction is either react the halide by using KOH and NaOH, right. It can be KOH or it can be NaOH also. You will be getting the alcohol, or else you use moist Ag2O, you will get the alcohol again. So, reduction of your carboxylic acid, acid chlorides and esters. So, you can reduce carboxylic acids, acid chlorides and esters, and for reduction you use reducing agents like lithium aluminum hydride. So, you are having a lithium aluminum hydride here. So, you have an acid chloride. For example, G, if it is Cl, it is an acid chloride. That is, here you have a carbonyl compound. This is nothing but a carbonyl compound. So a carbonyl compound can be anything. It can be acid chloride, can be carboxylic acid, or it can be ester. But the logic is, if you reduce with lithium aluminum hydride, you can convert that carbonyl compound into an alcohol. So this is an important reaction, which is Bevialt-Blanc reduction. So in this reaction, what is happening is that if you have an ester, right, you have RCO, you have an ester and you are reducing it in presence of sodium and ethyl alcohol. So sodium and in presence of ethyl alcohol is another reducing agent to convert a carbonyl compound, here specially it's an ester, to an alcohol. Here the other important logic is, I will be getting two alcohols. One is RCS2OH and one other is R-OH. So this R dash will fetch an alcohol, this R fetches an alcohol, which is RCS2OH. So here the mechanism is explained here. So whenever I have R dash or whenever ester R1, R2 at the other ends and you have COO. So first what I am getting is, first obviously carbonyl compounds are favoring nucleophilic addition. So nucleophilic addition takes place. So after the immediate step, what is happening? Immediate step, your OH ethyl alcohol is there. First sodium is getting added and afterwards what happens? Your alcohol substitution takes place because of ethyl alcohol, and again you are using sodium, right? Then again you are getting addition, I mean it creates a negative charge here. So because of this, now what happens is, this hydrogen shifts here and again this negative charge present here, this negative charge shifts here, because of which you will get one alcohol here, right? I mean you have RCOH, still you didn't get an alcohol, this is an aldehyde. So once you get an aldehyde, but remember here itself you are getting alcohol, one alcohol is R2OH you are getting here, and the remaining product is an aldehyde. This aldehyde, with the help of the same reaction again, the same process again, you are again adding Na, again adding with ethyl alcohol, again you will get an alcohol, and finally you again use Na, again use ethyl alcohol, again definitely you will be getting an alcohol. So next, reduction by boron trihydride. It's a simple process. It's a simple process where if you are using BS3 and H2O, right, you know reduction is taking place. So you will be getting again two alcohols here. One is RCS2OH and the other is R-OH. So the mechanism is explained here. So if you are having BS3, so you will be getting, I mean if you have BS3, then BS3 gets added here, then you can see the resonance which is possible here. Because of this you will be getting the first intermediate compound, and this will be converted into this, and again you are using BS3 again gets added here, I mean you are having you are adding another BS3 here. So finally you will be getting an alcohol. The important process is that, the important concept of this whole reaction is that you will be having two alcohols. Reaction of aldehydes and ketones, just like your carboxylic acid or ester can be converted into alcohol, even you can reduce a given aldehyde and ketone. So reduction by your reducing agent, aldehydes gives primary alcohols. So if you reduce this, what is happening? Reduction is nothing but what, guys? Reduction is nothing but addition of hydrogen. So basically you are adding hydrogens, as simple as that. So if you have a reducing agent, you are adding how many hydrogens here? RCOH and RCS2OH, you are adding two hydrogens, right? So one hydrogen is added here and one hydrogen is added to this carbon. So ketones give secondary alcohols, the aldehydes gives primary alcohols, ketones give secondary alcohols, because simple, you have H here, you have OH here, already there is R here, already there is R here, that means your alcohol will be a secondary alcohol. This is a 1 degree alcohol and this is a 2 degree alcohol. So these are some important points to be understood. NaBH4 and aluminium isopropoxide reduces only one carbonyl group and do not affect other group. If you have NaBH4, sodium borohydride, and aluminium, right, aluminium isopropoxide, they reduce only one carbonyl group and they do not affect other group, right. For example, you have your aldehyde group and you have NaBH4. Here, yes, we may think that alkenes can also be reduced, right? Alkenes can also be reduced to give alkenes. So here there are two reduction possibilities. One is the reduction of alkene, other is reduction of aldehyde. But remember, only one aldehyde is getting reduced to alcohol and there is no effect on your unsaturated compounds. But lithium aluminium hydride, if you have a lithium aluminium hydride, that lithium aluminium hydride, it has no effect on double bond and triple bond. But if you have a beta aryl alpha beta unsaturated carbonyl compound, then your double bond also gets reduced. For example, this is what this is. For example, this carbon is alpha carbon and this is a beta carbon because it is attached to the functional group. So what is happening here, if you have a beta aryl and this is alpha beta unsaturated carbons, right, unsaturated carbonyl compound. So according to lithium aluminium hydride reduces alpha beta unsaturated carbonyl compound. That means this can be reduced and this can also be reduced to a given alcohol. So here also you can see that it is alpha beta unsaturated aldehyde or carbonyl compound that can be reduced to alcohol. Reduction by Grignard reagent. So you can also get alcohols by reducing Grignard reagent. The logic is that Grignard reagent reacts with aldehydes. I already explained this in the concept of your aldehydes and ketones, right. Grignard reagent reacts with aldehyde, right, reacts with ketones and you will get an alcohol. For example, let's take acetaldehyde. So what is happening? Grignard reagent actually adds R to the carbon and that increases the number of carbon atoms. So initially you were just having acetaldehyde, but finally you will be getting 1 degree alcohol because your R is getting attached to a carbon. Similarly here also, if you have RCOH, I mean here another R gets added, you will be getting a secondary alcohol. Here this R gets added here, so you will be getting a tertiary alcohol and OMGX will be removed after further hydrolysis process. How to get from primary amines? This is another interesting concept. Even you can get alcohols from amines. This is the reagent. NaNO2 and HCl is the famous reagent, right? You will be understanding its importance in generally in the concept of aniline, right, where you will be getting a diazinon salt and the important properties of diazinon salt. So you can refer for the session of amines to learn more about this diazinon salt concept where amines react with NaNO2. So if it is a normal aliphatic amine, with the help of NaNO2 and HCl, you will be getting alcohol. So this reaction proceeds through carbocation formation. So rearrangement alcohol is obtained. That's why rearrangement is possible here. From oxiranes. So even your oxiranes react with Grignard reagent to give monohydric alcohols. So you can see here you have an oxirane. What is oxirane? This is oxirane. So just like your Grignard reagent reacted with your aldehydes and ketones to give alcohol, the same mechanism is happening when Grignard's reagent reacts with your oxirane. So it reacts with oxirane, your R gets attached to carbon, then you will get O minus MgX, then it undergoes hydrolysis, then you will get an alcohol. So students, after going through video lectures and video solutions, so you might be still having some doubts, right, related to a new theory or related to a numerical. So what you have to do is just go to our website www.askIITians.com, and on the website just select the tab Ask a Question, and on the right side of the screen you can find Ask Experts icon. So on this icon just select your category. For example, if you have a physical chemistry question, and just post your question. Likewise you can post your organic chemistry question or inorganic chemistry question, and you'll be getting the solution and answer for your question within 24 to 48 hours. So students, in this part we have learned how to convert a given aldehyde, a given alkene or a given amine to an alcohol. So we have learned how to prepare an alcohol from different organic compounds. So in our next part we will be discussing about how to prepare a phenol, how to prepare an ether, right? Till then just stay tuned to our sessions, right? So have a good day, take care and goodbye.